Hi there. So we're going to start a challenging lab called What's in the Bottle. So the goal here is eventually we're going to give you 4 samples, or show you digitally 4 samples of things that you don't have to figure out what they are, but you have to figure out what type of bonding they have. So in order to get to where you can do the unknowns, we're going to start with some knowns, and you should be able to figure out from what you see in the names of these what their basic type of bonding is. And we're going to run a whole series of tests. So starting with color, and I'm going to put a small sample of each of these substances on here so that you can see it. This is paraffin wax, just like candle wax. This is sucrose. This is aluminum. Sodium chloride. Okay, so now we're going to run solubility tests on our 4 different substances. We're going to test their solubility in water, which is a polar solvent. We're going to test it in oil, which is a nonpolar solvent, and also in ethanol, which is a vastly less polar solvent. So here we go. I've already put most of my solids in. I'm going to go ahead and actually just do it this way. Put my sodium chloride into the last few. So you can see that each thing across this is all paraffin, and down I'm going to test water all the way down so you can see how my chart works. Okay, so now we've put all of the solvents in with our potential solutes and see what happens. As we look across at the paraffin, I still see paraffin very clearly in my water and ethanol samples, but it has mostly dissolved in my oil. The sucrose is sort of the opposite. It's disappeared. I no longer see it in my water sample. I still very clearly see it in the oil, and maybe I see some there in the ethanol, but it definitely dissolved it, at least partially. My aluminum is still there in every single case, very visible, clearly did not dissolve. My sodium chloride, again, clearly dissolved in the water, clearly did not dissolve in the oil, and the ethanol is sort of cloudy and potentially somewhat dissolved. Okay, so now we're going to test conductivity of our known samples. And conductivity can be tested both as of the pure undissolved sample, or if the sample dissolves of that particular sample as it's dissolved. Now, we don't have a conductivity meter today. We have this light bulb that you'll notice I don't have it plugged in. If I plug it in and I connect these 2 wires, then my circuit will be connected and my light bulb will light up. Okay, so I'm going to be really, really careful not to connect these 2 wires with myself. Okay, so plug it in, and let's first test our paraffin wax. I have a large chunk of it here, and nothing. Okay. Now my sucrose, I'm going to have to keep in the beaker, but I can insert the wires down in the beaker. And we are not getting any conductivity. My aluminum, I'm going to have to aim carefully on this one. Get my 2 probes to touch it. Ah, we definitely have conductivity on this one. And my sodium chloride, again, just like the sucrose, we'll test it this way. And again, I don't see anything happening. Okay, so those are the tests of the pure solids. Now, I'm not going to attempt to dissolve the paraffin and the aluminum in water because we already tested their solubility and they don't dissolve in water. So I'm just going to test the sucrose and the sodium chloride. And let's test our sucrose. And again, nothing happening. Okay, and finally, our sodium chloride solution. And this time we have some conductivity. Okay, now that we have solutions, we can do one other test, and that is to test the pH of those solutions. Again, I'm not going to test the pH of my known paraffin and my known aluminum because I can't dissolve those, and since I can't dissolve them, they will not react in an acidic or basic way. But I can test my sucrose. So I will dip the pH paper in there, and I don't get a tremendously different. I'd go maybe 5 for the pH, maybe 6. And again, probably the same thing, probably a 5. You might make a case for 5.5. Test. Our second to last test is going to be reactivity. So I'm going to start, again, I have made a basically like an Excel spreadsheet almost, with my paraffin across the top, my sucrose, my aluminum, and my sodium chloride. We're going to test hydrochloric acid, sodium hydroxide, and magnesium. And here we go. So this is my HCl, and I will put some drops of that into each of my wells. Okay, super exciting results. In this particular instance, when I'm looking at it, I don't see much of anything happening. Now, you might see some dissolving of your sodium chloride, but remember, our hydrochloric acid and our sodium hydroxide are both in water solutions. So you have to keep that in mind. And the darkness that we see here, that is the magnesium powder. So when I put the magnesium powder on, I didn't see any dramatic changes. It just seemed to mix with the substances. Okay, so now we're going to run a relative melting temperature test. Now, we're not using any thermometers here, so I'm not actually going to be getting specific temperatures. We're just going to be figuring out which thing melts most quickly. And this one here is my paraffin. This one is my sucrose. This is my aluminum. And this is the table salt or sodium chloride. And you can see while we're watching that the paraffin is clearly melting very rapidly. Of course, they're all under the same basic heat. So clearly the paraffin has the lowest melting temperature, and we're waiting to see changes in any of the other ones.
Okay, so this has been a couple of minutes here. So we took the paraffin off because it was starting to get very, very stinky. You can see our sucrose has undergone some changes, and our aluminum and our table salt, our sodium chloride, have really not. So just a little add-on to that melting point. We didn't really see a visible change to the aluminum pieces, but when we went to throw it away, these two did sort of fuse together, so they were at least melting a little bit. The sodium chloride, nothing.